Today I have the pleasure of presenting the research piercing the veil of TVL, DeFi Reappraised. This work is co-authored with Dr. Yebo Feng from Nanyang Technological University, Professor Jiahua Xu and Professor Paulo Tasca from University College London and the Exponential Science Foundation. So what is TVL, or total value log? TVL is an important metric in decentralized finance. And similar to the concept asset under management in traditional finance, TVL represents the total value of assets staking or held by a DeFi protocol, a decentralized finance protocol, a blockchain, or the entire DeFi ecosystems at a specific moment for the yield generation purposes, and indicating the size and popularity of the DeFi ecosystems. So TVL figures are reported by the DeFi tracing website, with the DeFi Llama being the most widely recognized one. On the right-hand side, you can see a screenshot of the DeFi Llama TVL dashboard. And our paper examined the double counting problem in TVL, which originates from the inherent composability of DeFi. DeFi composability refers to the capability of one smart contract to accept tokens generated from another protocol seamlessly, allowing tokens to be chained and integrated to generate new tokens and financial services. On the right-hand side, we show a flowchart illustrating the complexity of user behavior in decentralized DeFi ecosystems. Let's walk through an example. So suppose I have $1,000 Ether. As a DeFi user, I can deposit my $1,000 Ether into Lido to generate the $1,000 STEs to earn rewards and maintain my liquidity. And then the $1,000 STEs can be staked and generated the WSTEs. The cross-protocol wrapping is also possible. I can use the $1,000 WSTEs as a collateral to borrow the $571 DAI. During this process, the wrapping process can be repeated multiple times without injecting any extra capital. If we take a closer look of the flowchart, the gray shading represents the $1,000 initial value that I deposited in, and the green shading represents the TVL, which is about 5 times the initial value that I deposit. This highlights a critical point that TVL can be artificially inflated through the recursive wrapping without injecting any capital. To make things even worse, most DeFi tracing websites report only inflated TVL without revealing any other accurate underlying value of the DeFi. And this misleads the DeFi user, investors, and researchers, because most of them are based their research and financial decisions on an inflated matrix for the DeFi protocol evaluation. TVL double counting often results from 2 common operations, the wrapping and leveraging. On the right-hand side, we decompose the large flowchart and to show 4 subfigures illustrating the mechanisms of wrapping and leveraging, along with their corresponding TradFi analogies. Let's start with wrapping. Wrapping means that deposit existing tokens into smart contract to generate new tokens. So in our scenario, the STEs is wrapped into the WSTEs, and the WSTEs is wrapped into DAI. During this process, both the value of STEs and WSTEs are counted into TVL. As a result, the same value are counted twice due to the 2 levels of wrapping. This mirrors the hypothecation process in the traditional finance. A credit-worthy lender can lend money to the borrower and simultaneously issue a note as a financial asset. Due to her strong creditworthiness, she can use the note as a collateral to borrow the money from the bank. And next, let's move to the leveraging. Leveraging means that invest with borrowed asset. So in our scenario, suppose the DeFi user have $2,000 DAI. She can use the $2,000 DAI as a collateral to borrow the ETH, and then she can go to the decentralized exchange to swap the Ether back to DAI and reinvest the DAI into the Aave. This process mirrors the leveraging in traditional finance. So for example, if someone is speculating on the real estate price, This guy will use the existing real estate as a collateral to borrow money and reinvest into the real estate market. To better illustrate the TVL double counting problem, we adopt a balance sheet approach. A balance sheet describes the financial positions of DeFi protocols. The aggregate value log can be regarded as a substantial proportions on the asset side. For DeFi ecosystem, we apply the consolidated balance sheet, trying to illustrate the financial statement on an aggregate basis. And using the non-duplication process, we can effectively eliminate the double counting. So for example, for the wrapping scenario, when the STEs is wrapped into WSTEs, the TVL is only $1,000. However, if the WSTEs is wrapped into the DAI, the TVL is like is 2 times of the initial value deposit, is 2,000. However, if you look at the consolidated balance sheet, we only have 1,000 adjusted TVL. For the leveraging scenario, suppose we have 2,900 Ether in the Aave, and $1,000 Ether and $1,000 DAI in the Uniswap as the initial capital. When the user when the user used 2,000 DAI as a collateral to borrow 900 Ether, the TVL of this system is 5,600. However, when the user swap the Ether back to DAI and redeposit the DAI, the TVL of this entire system becomes 6,500. But if we looking at the consolidated balance sheet, the underlying value is only like 5,600. For the existing methodology for the double counting problem, the DeFi Llama provides the DeFi Llama adjusted TVL, which is calculated by aggregating all the possible eligible protocols and then summing the TVL across all blockchains. However, this eligibility of this protocol is arbitrarily determined. That's whose validity we challenge. Therefore, we introduced a new metric called the total value redeemable, or TVR, which is defined as the total value that can be redeemed from DeFi protocol or DeFi ecosystems. For the traditional TVR framework, we include both the plain tokens and derivative tokens. But for the TVR, we only include the plain tokens. Next, we empirically measure the TVL and TVR. And we observe that our measurement finds substantial double counting in DeFi, which is shown by the gap between the red line and the black line. And we also observe that the DeFi Llama's adjusted TVL also cannot truly reflect the true value of DeFi, which is represented by the gap between the blue line and black line. We also observe that dominance of the top 4 protocols increases following the Luna and FTX collapse, where the double counting proportion decreases after those events. We also conduct the network analysis for the top 6 protocols, and we observe that both the TVL and TVL to TVR ratio of the protocol, excluding Lido, decreases from when the TVL reaches the maximum value and after the collapse of Luna and FTX. We also show that the TVR is a more stable metric compared to the TVL, especially during the market downturns. A 25% of the decline of the Ether price will lead to 1 billion greater nonlinear decrease in TVL compared to TVR. And here are the key takeaways. Due to the sensitivity to the double counting, TVL is flawed, manipulable metric for DeFi value. And DeFi value can be more reliably measured through TVR using accounting principles. TVL is more stable during the market downturn. And DeFi money multiplier can be constructed analogous to the TradFi money multiplier and can be a proxy for the protocol complexity. And thank you so much for the attention. Yep.